All right, it's time for pattern 3. Pattern 3 is a little different. Pattern 1 and 2, we're starting in the negatives. This one starts all positive. So we are going up by 1 again on the x. And once again, the y is looking a little funny, but it's all going the same direction this time. So we're going minus 3, minus 5, minus 7, minus 9. So let's put that in. Change was minus 3, minus 5, minus 7, minus 9. I think you might be able to see quite clearly that every single time we're going minus 2, minus 2, minus 2. So the next one we should have minus 11, which means at the sixth term, we should have minus 32, keeping with our pattern. So let's set up our structure again. It's f of n plus 1 equals f of n plus change in y. So the change in y, or the pattern, pattern for the change in y can be described as minus 2n, because it's subtracting every time. So minus 2, minus 2, minus 2. And then right here, our second piece, minus 2n, minus 7. A lot of negatives this time. Let's plug in 1. Negative 2 times 1 is negative 2, minus 7. The change was indeed negative 9. Negative 2 times 2 is negative 4. Negative 4 minus 7 is negative 11. That is indeed the change that we had. And so this is our correct pattern. So our rule for pattern 3 is f of n plus 1 equals f of n plus our change is negative 2n minus 7. So if you look over here, we can see this change, negative 9, negative 11, it'll be negative 13. What's our starting value? This one's going to take a little bit more work. So we got to go backwards. We have to figure out what was the term before 1. So at 1, we had 3. And so we have to go backwards. What was, ooh, these numbers are messed up. Sorry, y'all. This was supposed to be 1. This was when x was 1. This was supposed to be when x was 2. This is supposed to be when x was 3. This would be when x was 4. And this one was x was 5. Did I mess up on the other one? Oh, praise God, no. Okay, so back to what I was saying. We need to figure out what was it at 0. So let's just go up, all right? So we're at the table. Let's insert a row right above. We know that at 0, the change would have to be negative 1 to follow the pattern. So let's look. Insert another row above over here. So if the change was from here to here minus 1, that means we had to go 4. 4 minus 1, 3. 3 minus 3, 0. 0 minus 5, negative 5. Negative 5 minus 7, negative 12. So that has to be our starting value. We started at 4. All right, bada bing, bada boom. This concludes recursive rules for quadratic patterns.